Sophie would also be able to record. Let me see.
Awesome. Hi, Sophie.
Hi, long time no speak. How are you?
Fine. How are you doing too?
Yeah, I'm gutted I'm not in Lagos this year, but all good.
Yeah, I know, right? Glad to have you all here.
Good. Yeah, so Wale is almost there. He's updating his Zoom, so it should be a few more minutes.
All
Sorry
right.
about that, everyone. We're not, nothing's happening right now. We're just waiting for the tech issues to be fixed. Just bear with us. Thank you.
Okay, finally, I'm in the breakout session. Um,
Hi, Wale. Welcome. So the floor is yours.
all right, thank you, Sophie. Hello, everyone. This is Wale Ademola speaking. So Lincoln was trying to add me to the breakout session, but finally I was able to do that myself. I don't know, are we starting now, or is there a need for someone to speak from the data science team before we kickstart?
Hi,
Please, I'm
Wale.
guided by the protocols.
So Fumini here. Just
Hello.
you're doing well. So thank you so much for
Yes, I am.
joining. Yeah, so you can start off right away. So Sophie has been sharing the materials, and I believe everyone is up to speed. So we can get started right away.
All right, great. Thank you very much, Funi. Do I necessarily have to be a host on this breakout session to share my screen, or have privileges? I am not allowed to share my screen yet. But while that is being done, hello everyone. My name is Wale Ademola. A geospatial analyst from the GRID3 team, working at FlowMinder. I have my colleague here with me, Sophie, and I'm sure she has done her introduction. If not, I would just say she should quickly say a word or two to introduce herself before we get started, and I'm able to share my screen.
Hi, thanks, Wale. No, I didn't really introduce myself. So I'm working with Wale on the GRID3 program. We're both working at FlowMinder, and I'll just be helping in the background answering some question in the chat, but Wale will be the lead trainer today. Thank you.
All right, thanks, Sophie.
Okay, just
am
a
I
moment.
able to?
Yeah, so just a
Right
moment,
now?
Wale. Yeah,
Okay.
so yeah, I'm sorting that out now.
All right, good. Thank you, Fumini. So while we're still trying to sort that out, I'm happy we have as much people in the room today, and I appreciate you all joining this session. It would be good to have a feel of those that attended the overview session, the first session we had on the 20th of November now I can't remember the dates. The day we started the bootcamp itself. If you attended the GRID3 session, the first GRID3 session, can I just get you to confirm by raising up your hands in the chat or in the participants section? Just a show of hands. That would be great to just get a feel of those we're speaking to, if there are new faces, and understand the audience, so I know how to either recap or follow through with conversations. Great. So I guess there's quite some people that attended the first session, and there's a lot of new people joining us today. That's good to know. While we're still also waiting for me to be able to share my screen and get started, can I just ask that for those that are able to, can I ask for you to turn on your screen, your video, so we can take a selfie photo, at least to get it started and start making up the noise on Twitter. You can start tagging the GRID3 Twitter accounts, indicating that you're part of the session and whatnot, sharing your experiences. That would be great. So if you can turn on your video, I think it'll be. I'm going to turn on mine now. That is it. So you get to see my face. Great. I don't know, Sophie, what's the protocol here? Are we going to ask to smile before we take the picture, or?
I just thought Nigerians always smile. I didn't have to ask. But yes, guys, give me your biggest smiles so I can take a screenshot. Thank you.
All right, good. Yeah, so that's the smile we were looking for. So please feel free to tweet at us on our Instagram account, Twitter account, sorry, at GRID3 Global. Sophie, I hope I got that right. I mixed that up a lot. But Sophie's also going to put it on the chat, so you can pick it up from there, and you can tweet at us. Hopefully, ask some questions around the session today, if we are not able to get to you to ask your questions. So, some of our data science experts would respond to your questions as appropriate. Still waiting to share my screen. What's the status on that like? So you can turn off your video now, just to save some bandwidth. I'm going to turn
it's
off
been
mine
run.
as well.
Yeah, just a few minutes. I'm having
Okay,
a big
great.
technicality here.
Okay, that's fine. So what I would also ground rules before we get started with the session, I would appreciate if all mics are muted unless you are required to speak or you are called on to speak. So we can avoid some background noise. We can avoid a lot of background noise. I think that will be appreciated a lot. And please also, if you have questions, throw them on the chat. We would pick some questions from the chat if we have time, if the session doesn't run over, and answer them. And those that we cannot answer, I think we would send response or answers to the questions and share with the data science team who would also extend our responses to you after the session. There's one of my colleagues that is supposed to be on this call that she had another engagement, but she's going to be joining us in the course of the session. Her name is Alina again, and she'll be taking the third session, third Geospatial Analytics session. So that is to say that this is the second session for the Geospatial Analytics, and we have one more session after this session. That's the starting from, I think, 2 or 3. I think 3. So please, and it's a continuous and follow-up session from this. So if you are intending to go through this session to learn a lot, I would advise and suggest that you also join our third session to consolidate on what you're going to be learning from this session. I think we would be able to give you as best as possible the full package of the training on the use of geospatial data analytics for insight and informed policy directions with the 2 sessions we have left. So I'm just giving a lot of general information at this point, hoping that as quickly as possible I can get to be able to share my screen. Please bear with us.
Yeah, so working on that, please just bear with us, everyone. Just a few minutes now. It seems it's a bit of a general issue, but it's currently being sorted out. Might just take a little while longer. Okay.
Okay, that's fine. So we save up time. I was hoping to do a recap of what we talked about in our previous session. And so I'll just go ahead and do that now without having to share my screen. So it will be good to get some responses in the chat, not necessarily you speaking. If anybody can remind us what we talked about in our first session as regards to GIS. What's the full meaning of GIS? GIS. So I want to get some responses in the chat. What's the full meaning of GIS? All right, great. Thank you very much for your responses. So a couple of people have gotten it right. GIS is an acronym that stands for Geographic Information System, and it's a tool for mapping and analyzing things that happen on the Earth. So all information must be referenced to a particular location or point in the Earth. And like we talked about in the last session, there are 2 main types of data model in the GIS system. We talk about the raster data model, which is also called the continuous data, which, for example, are elevation, earth surfaces, and whatnot. We also have the vector data model, which is mostly discrete, which includes point locations, point lines, and polygons. Rasters are more of grid cells, more like a satellite imageries. And so that's the 2 main data model we have in the GIS environment. And we also talked about a couple of range of applications of GIS to inform policy directions and decisions in a number of sectors, which GRID3 has been doing so far. And we shared some example of what we've done in those few areas. And we also talked about how you can combine multiple data sets together to actually.
Wale, so could you try to share your screen now? I think you should be able to share your screen now.
Fantastic. So I'm able to share my screen now. So I'm just going to go ahead and share my screen. With a show of hands, can I get people to confirm that you can see my screen now?
Yes, please.
Okay, great. So I'm just going to go ahead and start my sorry. I'm going to start the presentation. And great. So like I said, today we're going to be exploring GIS data using QGIS, and I'm going to be moving as quickly as fast as possible, knowing that we're way behind in terms of what we need to cover for today. Can you see my chart screen? Can you see the chart screen I placed on the?
No, just the Google slide.
All right, great. So just to keep on touch with the comments on the chat. Yes. So today, our learning objective is to understand how QGIS can be used to load and process and analyze and visualize geospatial data. We're also going to be learning how to analyze greater population data using QGIS to aid decision making in the health sector. So that's the learning objectives for this session. And quickly, I'm going to run through some bullet points of which I've highlighted here. Quick introduction to QGIS. What is QGIS? The interface itself, giving you like a run through of the interface, spatial data formats, attributes, how to export or visualize data in QGIS, plug-in, geoprocessing, and also if you're looking to expand on the knowledge you're going to get from this session, where to get help from. That's what I'm going to be covering specifically in this session now. And after this presentation, we're going to be doing some live demonstration using QGIS 3.10. And we've shared the materials that are going to be used for that live demonstration earlier before now. And I would ask Sophie to please share a link to that material again in the chat box for those of you that have not gotten your hands on the material. So within the folder, there's a written instruction, a step-by-step guide on what we're going to be doing in the live demonstration, and also the data sets that we're going to be using in the live demonstration. So quickly, QGIS, core functionalities. In the first session we had, we talked about two main GIS software, which are QGIS and ArcGIS. ArcGIS is more of a commercial GIS software, while the QGIS is an open source and free for use software. So it's easy for you to just download from their website and get started with the QGIS. And that's why we're using QGIS for today. So what is QGIS in itself? QGIS began as a simple GIS data viewer and quickly grew into something that a lot of people were depending on. Underwent rapid and major development, harnessing capabilities of other platforms and add-on from community. So it's a community that is developing QGIS environment, and it has a user-friendly graphic interface, which enables you to manipulate geospatial data as freely as you can. And it also gives you the ability to add plugin for more functionalities. You can download the QGIS by going to www.qgis.org. And the reason why I'm running through all this is because it's fairly straightforward, and I believe we're going to be sharing the slides with you so you can actually get the information from the slides itself. But just to give you a feel of what it is, how the QGIS environment looks like. So this is, if you start a project in a QGIS environment, this is how it's going to look like generally, regardless of the version. Maybe some differences depending on versions, but in general terms, this is more like a generic view of how the QGIS environment is going to look like. And there are some key things that you would want to pay attention to. That's the number one, which is a drop-down menu. Just like every other software applications, you always have the menu where you can navigate to get some additional functionalities of the application itself. The second one is the toolbar. So The toolbar is like a shortcut where some functionalities can be easily clicked on to get going on it rather than having to look for it from the menu bar. But for every function on the toolbar, there's always an equivalent location within the menu where you can access that functionality itself. There's a layer panel. That's the three. If you look at my screen, you see the layer panel on your left, which shows you all the geospatial data layers that you are currently working with in this project open in the QGIS environment. So all the data layers that you're currently working with, either turned on or turned off, are indicated here. So you can click on them to navigate through them or make further analysis with them. There's what we call the map window. That's the 4. The map window is where all the data, all the geospatial data layers that have been loaded into the QGIS project file is visualized. So that's where you see the spatial structure of all the data you have loaded into the QGIS environment, and you can zoom in and zoom out. This is where you actually are able to more like integrate or interact with the data more visually. There's a browser panel. The browser panel, that's the 5, where you get to browse through your computer directory to probably load additional data or save additional data or just look at some of the data that you might be interested in. Then the status bar, that's below, and that's where things like the coordinate system you're working with, other information like the scale, the magnifier, resolutions are always located. So just generally, this is like a default view of a QGIS environment. Moving on, I talked about the toolbar, which was number 3 in the last slide. Giving you more details of the toolbar, you have things like the pan, which is very useful, the zoom, and different types of ways you can zoom in and zoom out. Zooming is very important in the GIS environments because there's always a lot of data. When you have a lot of data loaded in your screen, you're able to zoom into specific details of those data sets from in the map window and look at it and see how it looks. And also you can bookmark, you can refresh. And so these are just general names of the tools on the toolbar that you can make use of. And there's still some more. The attributes, these are the attributes bar, where you can identify features that are loaded on screen. You can run some feature actions, select, you can do some select, you can do some deselect, depending on how you want to select. You can open a field calculator. You can open your attribute table. You can show some summary statistics. You can measure, you can add some map tips, sorry, and you can put some text annotation. A couple of these functions we're going to be using during the live demonstration, so you get to understand how it's used. But before we get there, we just want to show you, maybe intimate you with some of the names of these features, and I'm sure that from its names, you can easily begin to deduce what they are used for. So on the attribute toolbar, there's one feature that is keenly out. That's the identifier tool. And you can use the identifier tool to display all the attributes of a feature. It provides a simple way of retrieving attribute data from a map feature. So for example, if you have a feature like this point called Lusaka, if you use the identify feature to click on it, it gives you all the information of that point and the attributes related to that point, which is very useful in scenarios where you're trying to understand more about the data sets you're currently working with and trying to get some more insights around what kind of features the data has and how best to utilize the data in some geospatial analysis. Yes, so quickly, when you use the identifier to click on it, it brings this identifier result, which shows you all the attributes associated with that point. In this case, it has a name, Lusaka, which is labeled as it is on screen, but there are some other information such as the label rank, the mega city value, the longitude, the latitude, the rank max, rank mean, population count. Some of these attributes you might be familiar with. Some of them you might not really understand, which would beg the question for you to get more insight around the data you're currently utilizing. So to get clarity around what some of these attributes mean, especially if you did not generate the data yourself. Maybe you downloaded the data from one location, or there is no metadata associated with that data to give you better understanding of the data. Good. The next tool we're going to be pulling out to talk a little bit more about is the statistics. So the base QGIS install provides a useful descriptive statistic panel. The icon is found in the attribute toolbar and is shown as this, the signature. So when you click on this and you utilize it, it gives you some statistics about the attribute or the feature you've clicked on. For example, the count, the sum, the mean, median, standard deviation, range, and some general basic statistic information, which can be useful for you to get to understand the data better, like I earlier said. I'm going to move it quickly. There's what we call the data source manager toolbar, which helps you create and add new data to your map. And these are the icons for them. So when you see these icons on your QGIS window, you begin to try to remember that they are the data source manager toolbar, and you can use them to create and add new data to your map. This is called the Geospatial. This is used to create new geo package layer. The one indicated is used to create a new shapefile layer, new spatial light layer, new temporary scratch layer. They are similar and they are somewhat different in terms of how they create new geospatial layer for you in the QGIS environments. But we're going to talking a bit about that in the live demonstration. And as well, like I said, you might not be able to get, we might not be able to spend as much time to explain all of this in this session. So you can easily use the names to get more information about them through a simple Google search. And I believe you'll get more information about what these toolbars actually do in itself. But like I said, you will be using a few of them in the live demonstration, so you shouldn't have to worry. Now, this opens the data source manager, which includes all or some of the data manager tools already shown on screen, and you can use that to actually add data to your window. Good. At this point, we're going to be talking about spatial data formats, which is very, very important. For those of you that have used or you've seen GIS file before on your systems, you would see that they always have a lot of, especially shape files, they always have a lot of multiple files with the same name. And in this slides, we're trying to explain what those multiple files mean. So shapefile are basic vector format files made up of several files sharing the same name but different extension. Now, under the basic bullet points, these are some of the general extensions that are included in the creation of a shapefile. There's a .shp, which stores the map objects information. There's .dbf, which stores the attributes information of the feature. There's .shx, which stores the index of the feature geometry. Now, there's some additional information that sometimes are created, sometimes are not, depending on the type of software you're utilizing and some the type of vector data you are working with. So things like .prj is a projection information which is only generated when you are using an Esri package such as the ArcGIS. Then there's the .xml metadata associated with the file. Now, like I said earlier, in some cases, some shapefile have metadata associated with them. So when they have metadata associated with them, this file will be attached to that shapefile. When they don't have, you would not see this file. So please pay attention to the extension so you can hopefully remember what this extension means. Then the QGIS, there's some QGIS specific extensions that are created. The version of the .prj for Esri is, for QGIS is .qpg, which also carries projection information. Then there's QML style information, and there's QIX spatial index. So that's generally, and you will see on the left, someone's mic, a lot of background. As you would see on your right, this is an example of how the files are named and created. So you see study area.dbf, and all these are packed up to make up the shapefile, just one shapefile. So when you have these 5 different files created, they all refer to one, they all combine together when it's being loaded to make up one shapefile in the GIS environment. Map layers and the layer panel. Now, you remember when I walked you through the QGIS environment, I talked about the layer panel. So a layer is a set of features of the same object type, e.g. point, lines, or polygon. A layer represents a single data set. Group folder allows you to organize layer appropriately. So in the layer panel, this is where a feature that has been loaded into a QGIS environment can be arranged, structured, and defined in terms of how it's represented, how it's presented in the map window. And you can group multiple layers together depending on what they represent and how best you're working with them, and you can separate them. If you look at the image, or if you look at the image on your right, you see that polygons is a infrastructure poly, transport poly, land use poly is a subset of polygons which has been grouped together. And under things like land use poly, you have other layers such as grazing area, fish farm, farmyards, which has also been grouped together. So this helps you structure out the different geospatial data layers you have or you're working with, so that you can not get confused and you can know which one you're using per time. So this is more of a structure thingy. The next one is the map layer and the layer panel, so which we're still continuing. So you can toggle visibility of the layer with this icon, which would be on the toolbar. And layer appears in drawing format, i.e. the layer at the top of the list will be the uppermost layer on the map. So in terms of the arrangement of the layer, so the layer on top would always be the one on top of your screen. So any layer underneath will be hidden under the layer on top, which means that in terms of order, it has more like a solid surface, or a region should always be underneath or below the layer that are just points. In scenario, for example, if you look at the map window, the blue icons are on top of the solid brown surface, which means that the blue icons in this layer panel is actually, in terms of order, is on top of the solid brown surface. And I think you can always reorder depending on how you think is best fit. You can always reorder the location or the positioning of your layers in the layer panel. Right click on a layer name to reveal more options. So you can always right click on a layer name to reveal more options of editing the layer or the data layer itself in terms of looking at the property, changing the color, maybe labeling the layer, and some other informations, probably looking at the attribute table and some other informations like that. So that's that about layers. Now, quickly, still on layers, before we drop the layers conversation, for you to understand, it's important for you to know which layers you're working with per time. And before attempting to work with a layer, make sure that it is highlighted in the layer window. And that is how it is, that is how you know it is an active layer. So whenever a layer is highlighted in blue, your layer panels like this, that is the layer that is active, and any edit on your map window, that is the layer that is going to be affected. So it is important for you to be conscious of the layer you're working with per time in your map window. And this is how you understand which layer is active and which is not. Please pay attention to that. Quickly, we're going to jump into working with tables. Window for displaying tabular data like a spreadsheet. So we call it attribute tables, and it's more like a window to display spreadsheets information in a tabular format. It has rows and columns referring to the records and fields. And the attribute table contains information about the layers feature. So if you look at the image below, you can, like we said, right click on a layer. Now this is the active layer. If you can see my mouse, this is the active layer. So what they've done is we've right click on this layer, and after right clicking on the layer, we click on open attribute table. So when we open the attribute table of that active layer, it opens this window which shows us the attribute information of that specific layer. And like I said in the text, it has rows and columns. It has rows and columns of specific information about the layer feature. Good. Still on the attribute table, I'm just going to point us to some key information on the tabs within the attribute table. You can save, you can make edits, you can save edits, you can toggle edits, you can delete selected features, you can select features using an expression, you can deselect, you can zoom maps to selected rows, open field calculator, create a new field. You can still work within the attribute table to edit a layer feature. And the way you select layer features is by clicking on the edge of each row, in each row value, each record on the edge to select them. Then also you can click on, if you want to select each column, you can click on the label or the header of each column to select the columns. So these are how to navigate your way within the attribute table information. The next thing we're going to be talking about is the print composer. The print composer allows you to set up your map ready for printing. Maps can be exported directly to PDF, SVG, or any major image file type such as PNG, JPEG, TIFF, BMP, as well as printed. So the map below shows us like a quick map that has been templated for print using the print composer. And you can see within the print composer, that's where we add info, things like the header of the map, we fit in the map, put some base map, put some attribute information, put the legend, and if possible, put the not arrow, navigation, and all that information that would make the map easily understandable by anybody that picks up that map and tries to read the map. So generally, this is where we do the like add the finishing touches to all our geospatial analysis to ensure that we are anybody that picks up a map that that has been finalized can relate and understand the information that is within the map. And as best as possible, I would, from experience, I would tell you that this takes a lot of time. And so it's always safe for the last. It's always safe for the last because you have to consider things like colors, the positioning, appropriate positioning, the size, the scale, and some other informations like that. Jumping through, because of time, there's also what we call the QGIS plugin. So one of the benefits or the unique features of QGIS is the ability to load in plugins. Like I said in the start of this session, QGIS is developed by a community, and as such, there's a lot of plugins that are being generated or created on a daily basis that helps simplify your ability to do certain things in the QGIS environment. So there are list of plugins that you can install, and you can easily search for them by clicking on the plugin in the menu bar and manage and install on the drop down of the plugin menu bar. So there are plugins with QGIS that allows users to further improve the functionalities of the software. For developers, there is also the option to create plugin and add scripts to allow further functionalities within QGIS. So when you get to that level where you are very confident in QGIS, you can actually develop your own or create your own plugin to perform specific functions that you want it to perform, and there is currently no plugin yet developed to perform that functionality. And yes, so when you click on the manage and install plugin, below on your right, you see a list of all the plugins, and you can search depending on if you are familiar with the name of the plugin you're looking for. But you can also click on each of plugin, which will give you like a quick explanation of what the plugin does, and some information around the number of people that have downloaded it, the rating, and general information of who developed it. So the processing framework. We're talking about the processing framework now, and generally what we're going to be talking about is the processing toolbox. And now the toolbox sets multiple directives for processing tools, and it's always located on your right, and you can always bring it out from your menu bar. It looks something like the image on the right of the screen, where we have the search and a list of processing tools that you can use to perform some geospatial, depending on what you're trying to achieve. And also there's a graphical modeler, string multiples tools together into a single window. So now there's a graphical modeler. What that means is that, so you can do like a model builder within QGIS, where you string multiple tools together to perform a particular geospatial analysis in a workflow setting. I'm sure I'm talking to data scientists, so you should be able to understand talking about in this phase. So this is the ability to just build a model and run the model, and it performs that specific function which you built it for. You can also have history, audit trail of processing steps and parameters. So you can also always view the processes that you've carried out and troubleshoot where if you have errors in between, or maybe it's not giving you the result you want. You want to find out where you went wrong or where you imputed the wrong value or whatnot. So that history would provide you that audit ability. Now the result viewer, you can also check the summary. In the result viewer, you can check summary and error checking, which is allowed. Batch processing automates the execution of a single tool in a multiple data sets. So also the batch processing helps you to automate a function on multiple data sets so as to simplify the process and as best as possible. So if you look on the image below, that's where you bring out the toolbar, the graphics modeler, the history, the result viewer, and all the informations that you would need to perform geospatial analysis. Now, this is like the bread and butter of performing geospatial analysis in QGIS. So this is this is always your run-to for doing specific things or performing specific functions. You always have to make use of one tool or the other to do one or two things, no matter how little or how complicated they are. So quickly, I've talked a lot about some of the functions available within QGIS environment. So I'm going to talk about how to use those functions in a couple of minutes before we jump into the demonstration itself. So processing tools. There's some of them are Clip. Clip helps you extract feature based on the extent of another polygon extent, e.g. study area. So you can clip raster by mask layer. So that basically means you're extracting a raster layer on the extent of another data set. If you look at the image on below, we have a data set that covers an entire area, and we have a small data set that maybe of a study area that we want to focus on, and we don't want the whole data set below. We just want a data set, that data set to focus more on our study area. So what we would use is a clip processing tool to actually extract the information on the larger data feature to specify just the information on our study area. And if you look at the map on your right, you would see that that has been done to just mask out the rest of the information we really do not want and just focus on the study area we are keenly interested in. And this helps you in trying to reduce the size of the data you're working with per time, and also try to make you more focused, and also reduce your processing time, especially when you're doing a lot of complicated geospatial analysis. Another tool that is of keen interest and provides is also very easy to use, is the buffer. Now, this creates a buffer zone around another spatial feature, e.g. buffer to estimate health clinic catchments. And if you look at the image below, what we have is, in the left, is a spatial feature indicating locations of maybe health facilities, school locations, you can name it, maybe filling stations, and or whatever you want to call it. In this case, it's not labeled, so we can assign it to whatever we refer it to. And what we are trying to do is we're trying to establish a buffer radius around those feature layers. So maybe we specify a 2 kilometer, a 3 kilometer, 5 kilometer. We can use the buffer geoprocessing tool to create that 5 kilometer radius around these specific tools, and it will give us something like what we have on our right. The buffer using the specific distance we've specified, and spatial feature itself. So with this, we can begin to understand what is within this buffer region surrounding this feature layer, the specific feature, the spatial feature we're interested in. And we can begin to ask more questions like how do facilities or people within this region interact with the feature? Or maybe if it's a health facility, how do they interact with the health facilities? Are people coming out from outside the buffer to these health facilities? Or, you can begin to ask multiple questions, but this helps us narrow down, give us an insight into the relevance of the spatial feature within its immediate surroundings. And it can be used for other reasons as well, depending on what you want to use it for, but it's a very easy tool for beginning some geospatial analysis. The next tool is, the previous tools I've talked about are mostly used for vector data sets. Now, the next two I'm going to be talking about also can be used for raster. Now, it's the raster analysis tool. Now, zonal statistics is one of the analysis tool that you can use for rasters, and what it does is it creates statistics of a raster layer for each feature of an overlapping polygon. Basically, what that means is we're trying to understand the statistical information of the raster within the specified boundaries of a overlaying polygon. And that generates like some summary statistics for us in scenarios where we have a greater population information, just like we see on the lower imagery. We can extract the total population within particular administrative boundaries, if these are administrative boundaries, and generate the summary statistics of that information as seen on our right. We're going to be talking more about this in the live demonstration, so I don't want to dwell too much on it. This is where we get to, like I said in the start of the session, that we cannot touch on every aspect that you need to know in the QGIS environment, but what we're happy to do is point you to directions of where some of these resources are, and you can always reach out to those resources at your spare time to learn more and gain more insights around how to work within the QGIS environment. So these are a list of resources online where you can get help, and also within the QGIS environment as well. If you click on help in the menu bar or press F1, you would easily be taken to a content help, and a content help where you can get more information about all the various functionalities of the QGIS, and you can also use the what is to find out more information about specific tools within the QGIS environment. If you're talking about API, you can look at API documentation, and you can go to the QGIS homepage to get more information. So these are a list of resources available to you, and they are freely available. You just have to go to the link and get the information you want. And at this point, I think I'm done with a run through of the QGIS environment, talking about it. We are going to be going into the live demonstration now. And there are a few things you need to be aware of before we get into the live demonstration, which I'm going to talk about in just 1 minute. The learning objective of the live demonstration is to be able to load, explore, and visualize raster and vector datasets in QGIS. So we've talked about the kind of datasets we have in the QGIS in the GIS environment, and we're going to be using those data, various data models in the QGIS environment in the live demonstration. We're going to apply a range of geospatial, geoprocessing, and analysis tool on geospatial data. And we're going to be using the GRID3 population estimate to determine suitable locations for mobile vaccination posts. So the last bullet point is more of like a question we're going to be, or more of like a question we're going to be troubleshooting and or developing an answer for. Maybe at this point it would be good for me to hint that for in a GIS environment, you're always, everything you do is always driven by a question in itself. Everything you do should always be driven by a question in itself. So for you to know which geospatial tool or analysis you're going to be performing, you need to have a question at heart you're trying to answer. And that would help you narrow down the kind of geospatial analysis you should be considering. And that's why we've posed the question here, which is to use the GRID3 population to determine the suitable locations for mobile vaccination posts. I'm going to stop sharing my screen now. I'll stop sharing the presentation. Oh, yeah, one more thing. With the material we've shared with you, I'll quickly run through the file structure of the material. So the file itself is called GRID3 DSN QGIS. Under the file, we have what we call the exercise folder. Under the exercise folder, we have the data. Under data, we have 3 folders: the raster, vector, and the output data. The output data is where we're going to be saving or storing the outputs of the analysis we're going to be doing in the live demonstration. And within the exercise folder, we have what we call the training guide, which is like a step-by-step write-up to help you walk through the demonstration with ease. And also after the live demonstration, you can always refer to this document to try to replicate what we've done. Because of time, I would just say, let me see if there are questions. I'm going to use 2 minutes for questions and answer at this point. Should I pick from the charts? I think it's best for me to pick from the charts. So I'm just going to read some of the questions that have been pushed in the chat while I was speaking. Okay, some people have actually answered it. Can you load? Yes, you can load a CSV that has coordinate longitudinal Qgis and split points. Yes, that's the correct answer. If you have questions, I would say maybe you'd raise up your hand and let me see if I can answer, and I'll point to someone and I'll answer your question. If you have a question, please signify with your hands up. So I see a question on the chat. Can QGIS be used in any form of predictive modeling? Yes, it can be used. Well, generally, you can use GIS. You can develop some predictive modeling within a GIS environment, whether you're using QGIS or ArcGIS or any other GIS softwares or application in itself. Yes, it's possible. But like I said, you need to be guided by the question you're trying to answer. Which is standard in any data science application in itself. Are KML part of data types that will meet? So KML are a form of GIS data, but they are not a standard format. They are more of like a customized GIS GIS data that was developed by Google specifically for their software. You can manipulate to get KML data into QGIS environment, but I think might not be as straightforward as you think. You might have to move through a couple of steps before you can get into a GIS environment, like a QGIS environment. Is it possible for data collected in a tabular format to be analyzed by GIS? Yes, it is possible if the data has longitude and latitude information or longitude and latitude information. It is possible to be loaded into a QGIS and analyzed by a GIS environment. For facility, how can we use QGIS for facility location? This question is, well, you have to get like the data, the geo coordinates of the facility locations you're talking about in question before you can be able to utilize that data in the QGIS environment. So that would have to do like with a few data collection. At this point, I would say keep dropping your question in the chat, and I see Alina on the call now. She would be able to answer some of your questions which responds in the chat, and I would move to the live demonstration itself now. Thank you very much. So just give me some minutes. Let me load up my QGIS environment. I'm going to share my screen again and try to load up my QGIS. So like we said, we're going to be using QGIS 3.10. It should look something like this when you're trying to load it up. If you don't have QGIS 3.10, it's not to worry. It just means that there might be some functions or tools that have been moved around a little bit, but it should be very similar to, it should be easy to navigate and similar to what we're going to be using today. So if you have your manual or guide material with you, a training material with you, you can look at the training guide, as I'm going to be following holistically to walk you through how to perform some very simple analysis in QGIS. So when you get to the QGIS environment, you begin to see some of the things we've been talking about through the slide. These are the menu. These are the toolbar with informations like creating new projects, saving, zooming, panning, and this is the menu. I hope you can see the menu, which has things like help, project, edit, view, layer, and this is the data source manager that we talked about. Just to give you get you familiar, this is the layer panel. This is the processing toolbar. Now, this is where the map window is going to be shown when I eventually open a project, when I eventually create an empty project, a new project. But you see recent, for those of you that have worked on QGIS before, you see some of the recent projects you've worked on and maybe some news information. So quickly, I'm going to start a new project. And what I just did was I clicked on the new project and the toolbar, which I can also do by clicking on the menu bar project and clicking on new. And after doing that, what I'm going to be doing is adding some of the data that we're going to be making use of today. I'll go into layers, add layer, and add raster layer. Now, it opens up this window for you. Then you can click on the address. You can click on the double dot on the side to open your browser and go to the location. And I'll go into the QGIS folder in itself. And like I said in the demo, in the slides, and the data format is very simple. You have the raster, vector, and output data folder. And since we're loading raster, I'm going to open the raster and I'm going to load the raster file. The raster file is one of the GRID3 data sets, population estimates, which is gridded population estimate. So when you click on the file, you click on add, and you can see it has been added to your screen. So you can click on close, and that has been added to your scene, and it's as simple as that. So basically, that's how to load the raster file. Just click on layer, add raster layer, browse to the location where the raster file is, and you would load the raster file. Now you will see that the raster file has been loaded as a grayscale. You can always change the symbology, but before we do that, quickly, we're going to be exploring the raster file in itself to understand more about the data. Like I told you in the presentation, that you need to understand the data you are currently working with. So Zoom application is not letting me click. Okay, so yeah. So what I'm going to do is you can zoom in and zoom out to look at the data in itself. So this is the raster file population estimates for the whole of Nigeria, the gridded population estimate for the whole of Nigeria. And it's available through GRID3. You can use your pan to pan and zoom in and zoom out to look at the data in more specifics, in more granular format. And like we said, the raster are gridded files. So you see these are grids. And if you click on the identify feature on the toolbar, which I explained in the slides, and you just click on any point of the raster, you see the values as seen on the lower right. You see the value of that specific grid, which in this case is 1.78. That's the attribute of that specific grid. And this just implies that that's the population within that specific grid. When you click on multiple grids, the value changes. the value changes, and it is included in what we call band 1. You can also explore further about the raster, further information about the raster. You can go to properties. You can go by going to right-clicking. You can right-click on the layer panel to show more information that you can use. Then go to properties. Now, under properties, you would see an information tab. When you click on the information tab, it would show or display all the relevant information as imputed by the provider of that data set about the data itself. And things like the name of the data is indicated there. In this case, it is Nigeria population version 1.2 gridded. Other information like the coordinate system is indicated, the extent, the units, the width, height, data type, which is float in this case. You would also get to look at some information such as the statistic information, minimum, mean, maximum, standard deviation. Now the pixel resolution as well. Where is the pixel resolution? That's the pixel size. Yes, this is it. The origin, and just general information. And also, yeah, you can also get information about where the data itself is stored on your system. And so those are some of the general information that are always included in geospatial raster data when it is loaded on your screen. Now, note regarding the pixel size, the population dataset feature in this exercise have pixel dimension of 0.00833 and minus 0.00833 in extension. This is an angular unit because the data is referenced by a geographic coordinate system. The value represents fraction of a degree of longitude and latitude. In this case, 0.008333 equates to the approximately 100 meters at the equator. So that's one thing you should pay attention to. So 0.00833 equates to approximately 100 meters at the equator. So yeah, generally, these are some of the informations that are relevant for you to understand and know before you start working with the data in itself. So like I said, we're still on the identifier too. You can click on other parts of the data and the value of each grid cell you click on would keep changing. Now we're on, if you're looking at the material part 3, where we're going to be looking at the symbology, how to change the color or visualize the data more appropriately. You can also always right click on the data in the layer panel and go to properties. Now we're still on the information. That is why we're still given this information where you're going to click on the tab called Symbology. Now, when you click on the tab called Symbology, it will give you some of the features or settings that you need to tweak to be able to change the symbology of the data that is currently loaded. It's currently in a single band. In the render type, it's currently in a single band gray, but you would change it to single band pseudo color. So, well, based on the training materials, you're going to be changing it to single band pseudo color, and that would change the settings that you're going to be seeing in the screen. You would specify clicking on the arrow. Clicking on this arrow, you specify minimum and maximum. In the accuracy, you specify actual slower. And you would now choose a color ramp. in this case, I already have a color ramp loaded. I already have a color ramp loaded, but you can always change the color ramp by choosing out of this color ramp indicated here. So I have, this is the one I'm using. You can change to divergent or depending on the color ramp you want to use. But I'm going to use the other one, the one I used before. So in the values, based on the material, we have 0, 100.75 to 201.5, 302, and the likes. Because this is just a training session, I'm just going to select this. If you don't see any value here, you can always click on classify, which would bring an automated value into this view. And when you click on OK, you would begin to see that the symbology has been applied. The symbology has been applied. Now, the reason why there's a lot of red is because I changed the value, and you can always delete, reclassify. I changed the value that it started with. So what it means is that there are a lot of values between 0 to 310. So if I want to have more granular symbologies there, I can always change the values that is expected to be represented, 0 to like maybe 10, 10 to like 200, 10 to like 200, and we can click on OK. Now you see that there are a lot of values with 0, but there are also a lot of values between 10 to 200, which shows the color of what do you call it? More like an orange. Now there are less grids with values above above 2. Why am I using white for 200? Sorry. I have to change this color ramp. So that we can see, I don't want to use white specifically, and the color ramp is not giving me what I want to. Yeah, that's more like it. So good. So you would see that there's a lot of values between 0 to 248. And now I can specify that this is 10, this is maybe 50, this is 200. And quickly, that gives us more granular variation between the color symbologies. Now you would see that there are less values above 200, and that's why you have less colors appearing, less colors with the darker red appearing across the whole country. So that's generally how to use the symbology to actually give your data a more appropriate color grading. And you can play around with these settings as best as you want to get the appropriate color that you want. You notice that I was also playing around with it to get the value ranges that I wanted, and also the color ramps that I wanted. Quickly, I'm going to move into clipping raster population data. And that is where we're going to be using some tools that that I talked about in the presentation. But before we do that, we're going to be adding a vector data. So we go to layer, add data, add vector data. Before we added the raster data, now we're adding a vector data. We're in file. So click on the browse panel on the side. I'm going to go to data, navigate to where the data is. I'm going to vector, and we are loading the admin boundaries. So if you want to load the vector data, you always click on the data extension that has .shp, which is always the shapefile. And that would actually load all the other adjoining files associated with that file in itself. So when we click on add, it automatically adds it to the window frame. And as you can see, the vector file is on top of the population data, which means that it is overlaying the population data. If we want to change the order, we can as well just drag and bring the vector file below the population data so that we can better see how both of them combines together. So that's how to add vector data. I've walked through, I've demoed how to add a raster data, how to add a vector data, and also how to change your symbology, how to look at your data in more detail using the identifier features. Quickly, we're going to be clipping, extracting the population raster for the population data for using this vector data. And what we're going to do is we're going to go to raster in the menu, go to raster extraction and clip raster by mask. So when we do that, automatically brings out this panel where we have to specify the input layer. Now the input layer is always the gridded population, the raster file that you want to clip. The mask is always the vector file you want to use to clip the raster file. And you can scroll down to, clip mask and specify where you want to save the output of this data. So I would click on save and I'm going to put it in output and I'm going to call it Kano _ Kaduna _ pop. So you can leave all of that information as default and just specify the inputs, the mask layer, and specify where you want to save the data. And let's click on run. And immediately we run the data, it's going to create a clipped file. It's going to create a clip file. So it's completed. As you can see, it's been completed. You can close. And it has created a clipped file called Kano Kaduna Pop with the extent within the vector file we used to clip. So if I turn off the population data for the whole country, you realize that the population for Kano and Kaduna has been pulled out from the whole population for the country. And the reason why that is the case is because we're using the vector file, the vector boundary for administrative boundary for Kano and Kaduna. For Kano and Kaduna. So that is that. So we can also change the symbology of this by also going to properties. The same way we did that, click on symbology, single band pseudo color, and add our symbology, which gives us a graded color format of the population, depending on the density of the population within specific location. Now, if you zoom in specifically, you realize that the higher density have the darker color, which is indicated in the legend. So places that are between population of 622 and 777 have the darker red as indicated. In scenarios where you want to get more legibility in this kind of map, you can always as well click on the vector data and change the color. You right click, go to properties, and also go to symbology. And in this case, you would see the color. You will see the color there. Because I don't want a specific color, I'm going to turn down the opacity. That's my preference. I just want the boundaries to be indicated. So it gives me this fine outlook of my population being seen within the boundaries of Kano and Kaduna. So the next step on, as indicated in the training guide, is for us to generate buffer zones for our health facilities. And for us to do that, we're going to be loading in another data, which we call health facilities. So the same thing we did for loading in the administrative boundaries, we're going to add layer. We're going to add layer, add vector layer. But in this case, in this time, we're not going to be, this time, we're not going to load the administrative boundaries. We're going to be loading health facility data, which is in the general. And it will be the Kano Kaduna Health Facility, which is indicated here. And immediately I do that, I just click on add. Immediately it is added, you would see it there. So you can data manager, and you would see your data has been loaded. You would notice that the population is on top of the health facilities, and it's because of the order in the layer panel. So you can always switch that by dragging the health facility data on top of the population, which helps you place the layer on top of the population. You can also use your identifier to look at the attribute of the specific values of the health facility. For example, you would see that this is a hospital in Kaduna. It's called specifically in Cubao, and it's a government hospital. It's called Pambewa. So generally, that's how to get more information about the data that you've currently loaded. You would notice that something happened when I was trying to use the identifier. The active layer that was selected was the population, and as such, when I used the identifier, the information I was seeing was the values of the population. So it was until I switched to the specific health facilities that information about the health facility became available with the identifier. Okay, so our session ends in 30 minutes. That's the information. I guess we're still within the time frame. So now that we've loaded the health facilities, and we can as well see it on the map, please, a useful tip is that you will notice that when you were loading the health facility, we indicated that it was UTM 32 knots. Remember that we are calculating any distance or area. Remember that when calculating any distance or area in GIS, it's strongly advised that you work in a projected coordinate system, such as UTM 32 knots. And that's why the data that we've loaded, the health facility data that we've loaded, is in the UTM 32 knots. Now the points represent main hospitals in 2 states. We will create a buffer zone for each hospital to approximately 15 kilometers. Estimates for health facility catchment varies, but 15 kilometers is a good measure for assuming a combination of walking and some form of motorized transport to the health facility. Now, based on the guide that we've developed, this is the information, this is what we're going to be doing. So we're going to be creating 15-kilometer buffer around the health facilities that has been loaded. Now, for us to do that, So we're going to click on the processing menu bar and click on the toolbox. In my case, my toolbox is already loaded, so which you can see with the check sign as activated. If I turn it off now, you will see that it's gone from my screen, and I can always turn it on, and it would appear on my right-hand side of the screen. So immediately that happens, you can just, in the search bar, type buffer, because buffer is the specific tool we are looking out to use. Immediately you type buffer, I'm going to close this. Immediately you type buffer, it will give you a list of tools that have the word buffer associated with them. And you would see under vector geometry, a tool called buffer. So you can easily click on it. When you click on it, because we don't have multiple data loaded in our layer, it has automatically selected the only point vector we have with its automatic suggestion as indicating that is the data we want to use. But in cases where you have multiple data in your layer panel, you might have to change the specific data you want to use as an input layer here. But in this case, we're using the health facilities, which is fine. The next information you want to change is, remember we said we're going to be creating a buffer of 150 kilometers. And the unit measurement here is in meters. So it's going to be 150 meters would be, that would be 15,000 written here to represent a kilometer. And yes, so now that that is done, we're going to put this as 10 in the segment. And that is just to give us like a nicer outlook of our buffer. The default is always 5, and so we're changing it to 10 to make it more look nicer and also a bit more accurate in terms of its roundness. The other informations are going to be left untouched. This was 2. You can leave other information as default, but remember to save to file. Remember to specify the location where you're going to be saving your buffer. So now we're going to, what name are we going to call it? Health facility, health underscore facility, underscore 15 kilometer, underscore buffer, underscore buffer. Good. So we specify the location where we want to save it, and we'll click on run. So immediately we run it, it creates the buffer for us. And as you can see, the buffer is already on screen, so we close this. So we would put you'll notice that the buffer is on top of the health facility point, so we can change the order and place the health facility point on top of the buffer, so we can see the health facilities in itself. And voila, so for us to confirm if what we did was actually accurate, we can use the measure to try to confirm the distance of the buffer we've created. We created a 15-kilometer buffer, and if you use the measuring tool, you would see that it's generally close to 15 meter, actually 15 meter, but because we're not selecting maybe there are some errors in the location I selected from origin to the edge of the circle. That's why it's maybe less than plus or take 15 or more. So that's how we confirm our buffer. And we can see that that gives us an accurate information around what we've created. So that's the measure tool for you. You can also use that. You can create a new measurement using another buffer to confirm. And like I said, depending on the accuracy of your selection of the health facility itself, it will be plus and minus, but it's close to 15. It's actually 15. So the next step is for us to calculate the zonal statistics. That's the part 5. Now, we'll use the zonal statistics to calculate the sum population within each health facility buffer area. The tool will calculate the statistic using the raster data and return the results into an attribute table of the health facility buffer data. Before we calculate the zonal statistics, I would quickly open up the attribute table of the health facility buffer. So we see that is not yet included there. So for you to open the attribute table of any data, any vector data, you can always right click and click on open attribute table. And that would open the attribute of the data you've selected. This is the attribute table of the buffer, health facility buffer that we've just created. And as you can see, the last information there is the source. The last information included in the attribute table is the source, and other information such as the owner, the name, the zone, region, and whatnot. So quickly, we're going to create a zonal statistics. For us to create the zonal statistics, we're going to be using the processing toolbar again. Just like we did earlier on, go to processing toolbar if your processing toolbar is not active, but ours is active. And we can type zonal statistics here, which would bring up the zonal statistics for us to use. Or if you know the location where the actual tool is, you can always navigate to it with the information, with the tabs on the processing toolbar. Because I want to show us where the actual tool is, I'm going to be navigating through it and just click on Raster Analysis, and on that Raster Analysis, we'll find our zonal statistics. So when we click on the zonal statistics quickly, we can select the raster we're going to be making use of. In this case, we're using the Kaduna population and the health facility buffer. And what we're trying to do is we're trying to create some summary statistics of the population within that buffer of the health facility. So I'm just going to put some prefix information to the column that is going to be created in the attribute table of the health facility buffer. So this helps me identify the new attributes or the new columns that are created. ZS means zonal statistics. So that's like a short form for me. And if you click on under statistics to calculate, if you click on the 2 dots or the 3 dots on the side, you can specify the information or the statistics you want to create. In this case, we specify the count, the sum, and the mean to be created, but we can also select all if we want to calculate the statistics for all the information. But I'm going to stick to just these 3 in this case, in this example. And when we're done with that, we can just click on run. So now it has run the process and it has been created. So also to confirm that it's been created, what we just have to do is go to the buffer and right click on the attribute table And we would see that some new columns have been created, which includes the count, the sum, and the mean of the population. Mean of the population. What we're interested in is the sum. What we're interested in is the sum. And as it stands, we have the sum information. Now, the sum is the total population value for all pixels within each of the health facility buffer. Within each of the health facility buffer. Now, facility N is the name of each health facility. Now that we confirm that the population information is now included in the health facility buffer attribute table, we can now finally try to answer our question, which is suggesting suitable location for mobile vaccination sites. Now, there are 3 potential locations has been spotted and proposed to you for evaluation in the north of Kaduna State. In this scenario, there is only funding for 1 vaccination post. You must assess the case and select 1 location to prioritize that are not areas already covered by existing health facilities, those that fall within 15 kilometers buffer zone of existing facilities. Now, based on the instruction, there are 3 potential locations that have been looked at to select 1 out of the 3 for actual implementation. And that data, that 3 suggested location has been provided, and I'm going to load that data. It's a vector data, so I'm going to load the data, and it's called, what we call it is WHO Health Facility Deficient Areas in this case, in this exercise. You can load the data, click on Add, Close, and you would realize that there are a lot of points on the screen now, so it might become difficult for you to identify which is which. There are a lot of ways to actually differentiate them. You can increase the size of the health facility and suitable proposed locations to differentiate them from the health facility locations, or you can also turn off some layers to look in more details of the new data that has been loaded. In this case, these are the proposed vaccination sites as provided to us. If you want to increase the size of the feature itself, you can just right-click and go to properties, and you would see a value called size and increase. You can just increase it and click on OK, which increases the size in itself, and that gives us like a differentiation of vaccination posts and health facilities. Lastly, on the slide, based on the 3 proposed vaccination sites that has been loaded on the screen and the buffer of 15 kilometers that has been calculated. To make the picture stand out more. Now, based on the placement of the 3 locations, which location is not already covered by existing health facilities that you would recommend as a suitable location for a mobile vaccination post? Now, if we look at the screen now, we'll realize that this proposed site is covered by a number of health facilities based on the 15-kilometer buffer radius. This proposed vaccination post is covered by a number of health facilities based on the 15-kilometer buffer radius. But this vaccination post is further from any health facility and its buffer of 15 kilometers. And ideally, this gives us our information in terms of from a policymaker direction, which health facility is most ideal for us to invest in to ensure judicious use of resources and an area that is not yet covered by existing health facilities. It would be this location, and you can use the identifier to get more information or insight about the specific proposed mobile vaccination post. And in this case, it is what we've called the post 2. So post 2 is the most ideal location that should be proposed and be developed as a mobile vaccination site. And that as the various steps we've undergone in this class, in this session too, has helped us answer this very simple question of which mobile vaccination sites should be invested in and developed for or funded to support the health interventions within Kaduna and Kano and Kaduna based on the proposed sites. And the answer is post 2, mobile vaccination site post 2. Now, that's the end of the demo session in itself. In this demo session, we've used a couple of tools. I've helped you to understand how to navigate your way around the QGIS environment, and also I've linked up the presentation we had this morning with the actual interface of the QGIS environment to give you like a sense of how to move around and how to perform geospatial analysis within this environment. Yes. And I am going to pause here now to see if there are any questions. I see a lot of people have asked questions in the chat, and Alina has been very helpful to answer some of the questions and most of the questions. But if there are any questions at this point that has not been answered, I would pause now to see show of hands and get people to ask their question. You can either ask your question on the chat or raise your hands up and I would call you out to ask your questions. Do you convert, okay, there's a question from Jerry. Do you convert the CSV to a shapefile first, or by loading it, it's converted automatically? Okay, so if you have a CSV file that has the longitude and latitude of, or the geo-coordinate of the specific locations that are being referenced, you can load it in automatically from the QGIS environment. Quickly, I'm going to show you that. You can open layer, add layer, and you would see add delimited text layer. That's the function that you use to load in CSVs, delimited text layer. And it would ask you for information such as the longitude, the X and Y, which is also the longitude and latitude of the specific, the column that has the longitude and latitude of the specific fields for you to load them. That's the answer to that question. I need more explanation on georeferencing. That's a question that might take us the whole day to answer. Alina, do you want to go for this one from John? So I can pause talking.
Sure, Wale. Sorry, I was just trying to unmute myself. Hi, everyone. I think I missed the introductions at the beginning. To answer your question on georeferencing quickly, it is quite a broad topic, but in short, georeferencing is basically taking an object that doesn't have any spatial information attached to it and then converting that object using a coordinate system so that it can be placed on the Earth's surface and on a map. That's a really quick definition. Just because of time, I don't think we have time to delve any further into it. But it's basically just assigning a coordinate system to the data so that you can present it on a map and work with it within a GIS. And if you're interested in knowing more, we could send some useful links, or you can look at it online where you can find out more about that.
Yeah, thank you, Alina. Thank you for trying to answer that question as short, getting that answer as short as possible. Like I said, if we're going to talk about georeferencing, we might spend the whole day here. Moving on to the next question, is it possible, Oluwaseyi, is it possible to search for clip, just like the way we search for buffer? Yes, it is possible. Let me just show you on the screen. So when you see clip, when you search for clip, you can always see clip. There are a couple of clips there, so you must try to decipher the one you want to do. And if you look at it, there are some clips that are used for vectors, and there are some clips that are used for rasters. So you should know which data type you're trying to use clip for before you apply the specific clip. So before you know the specific clip that is applied to them. That's the answer to that question. Range of, okay. I need more explanation on georeferencing. Okay, that question has been answered already. You can use Python. Thank you, that's correct. Okay, please, can we get useful links for georeferencing? Okay, for the georeferencing. Useful links for georeferencing. My quick answer to that question would be for you to start with this QGIS support. QGIS support, and within one of them, you would get like a guide to georeferencing, or better still, you can just do a Google search around georeferencing and you see a lot of help resources that can be pushed out to you on georeferencing, depending on the aspect of georeferencing you're referring to. Georeferencing is a very broad topic. Like, what's the difference between a raster and a vector? My network is be like example. So rasters are more of gridded, continuous data surfaces. For example, satellite images are raster data. Gridded data like the population estimates, as seen on the screen here, are raster data. So the population estimates, that is the Kano Kaduna population, is a raster data. While vector data are lines, points, and polygons. They are more of a discrete data, which includes lines, points, and polygons. I believe I've answered that question. I don't know if we still have enough time to answer more questions. I guess that's the end of this session, but we can still answer a few questions. Like I said, you can always tag us on our Twitter handle at GRID3 Global, and we'll try our best to answer some of your questions. And you can also share your experiences with us on our Twitter handle as well, and give us okay. Kabirat says she can now improve her BSc project. That's good. That's a good feedback. We would love as much feedback as possible.
BSc project. Data.
Okay, so Mary, are you trying to say something, or that's just an interference? Okay, I'm trying to understand the question from Samuel. How do we get more points later later for suggestions of vaccination points. I don't think I understand that question. I'm not sure I understand that question, so I can't answer. Apologies. Maybe you can retype and provide more clarity on the question. Please, can you briefly explain how you cleared out the remaining part of the map, leaving the part you worked on? Okay, so that was the clip. Oluyemisi is asking how I clipped out the population for just Kano and Kaduna and worked with it from against using the whole population for the country. Basically, what I did was I used the clip by mask for the raster and extraction, clip raster by mask layer. So that's what I used, clip raster by mask layer. And if you look at the training manual as well, training guide, as one of the materials downloaded or shared with you, the step-by-step guide on how to achieve that is also included. So you can always revisit it and try it out by yourself. Recordings in this, okay. How do we get more vaccination suggestion points? So to get more vaccination suggestion points, if you remember vividly when I said these were points that has been suggested, for example, by maybe Kaduna State government or by donors that want to fund this construction of vaccination points. So they suggested these 3 locations as probable locations proposed locations that they want to look at, and they want to find out which is most ideal, and which is most beneficial for them to embark on. So you can, they would be either you or the Kaduna State government would be the ones to suggest more vaccination points, depending on some of the criteria they've used to select these vaccination points. And they would come to you to ask, which of these vaccination points do you think, from a geospatial point of view, would be wise for us to invest resources in developing? And you would now be the one to answer that question by looking at the closeness of those vaccination points to an existing health facility based on a 15-kilometer radius, or this is an hypothetical buffer distance. If we're looking at the health system, I know that there's what we call 2, 5, and beyond. So 2 kilometers for fixed post, mobile, then outreach. Less than 2 kilometers for fixed posts. Between 2 to 5 is for mobile outreach. Then beyond 5 kilometers is for mobile. I think that those are some of the standards that are used by National Primary Healthcare for various campaigns or vaccination activities. But yeah, the principle still applies. You just need to understand what are the policies around the distance between the health facilities, and you can use that to trickle down to specific proposed vaccination posts that you want to pitch forward or suggest. Kazim is raising up his hand. Do you want to ask a question? I would say, please do.
Yes, sorry, sir. Thanks so much for the lecture. I missed most part of this lecture, so can I get the video or the step-by-step materials?
Yes, thank you very much, Kazim. So you can, yes, you can. I'll ask Sophie to share the link to the materials that has been developed for this session specifically on the chat again, so that those that are coming late would be privileged to download those materials. And as well, data science is recording this session. So a record of this session, a video record of this session will be shared with participants, I hope. I'm definitely sure about that. After now, where you can easily listen to the step-by-step of what I did in the QGIS environment, and use that to replicate the approach of doing it yourself. I think those are all the questions we have, and it's past 2, so I would say I would want to hand over to the data science team to maybe close the session or share more information about upcoming sessions. But please note that our next session is going to be starting by 3. And we're going to be deep diving into some other geospatial analytics using, and this time we're not going to be using a user interface like QGIS. We're going to be going more native or traditional by coding, like using programming languages like R programming to perform the geospatial analysis that we're going to be doing. And just that is just to show you that you can either use like a user interface like QGIS, or you can use a programming language to code out your specifications or the specific functions you want to perform in a QGIS in a GIS system. Our program is going to be used in the next session, so please come and learn more about performing geospatial analytics, and we would hope to see you there.
Thank you so much, Wale. People are still asking questions. So you can just know the questions. I think, Wale, would you like to address this one about Python? I think it's our community really loves Python. So
so I'm happy they're asking the questions about Python. When you come to the session, what I would say is when you come to the session, we'll give you more insight around would answer this question specifically, because I don't want to let the cat out of the bag yet, and I can assure you that when you come to the session, it's going to be fully packed, and the use of the ability to actually perform geospatial analysis on R or Python will be explained broadly, and how we can replicate whatever we're doing in R in Python as best as possible would be expatiated on, or we can give you like insight on how to do it.
Yeah, thank you so much, Wale. Thank you, everyone. Thank you, Alina. Thank you, Sophie. It's been an awesome session. I'm sure that can we all just drop some feedback? How was the session? Just drop feedback before we go. I'm sure that everyone enjoyed it. So let's head to Twitter, please. We can tweet at them. Thank you. Awesome. Great. Thank you. Awesome. Great. So let's head to Twitter. Let's tweet at GRID3 official. I think that's the handle. Or you can just search them on Twitter. Global, yeah, global. So you can just search them on Twitter. I'm sure that you see that. Thank you so much. So Sophie just dropped it in the chat window now. So you can tweet your experience. Let's know how it went. All right, great. So we'll go on a break now till 3 when we'll reconvene for the next. Thank you very much. Thank you, Alina. Thank you, Sophie, for answering all our questions. Thank you, Temitope. So we'll reconvene by 3 for the next session. All right, thank you, guys. So see you by 3.